Morning, everybody. The problems up here on the board are from page 79. I want to give you the opportunity to hear me explain these answers. If you have any questions, of course, just let me know. So here we go. So number 47 is asking you, you hold a book in one hand and a flat sheet of paper in another hand. Explain why the following book is a good example of free fall, but the sheet of paper is not. Well, in essence, the sheet of paper has a large surface area and a low amount of mass, so it's going to be greatly affected by air resistance. The book, not so much, because it has a greater mass relative to the sheet of paper, and air resistance is not going to affect objects that have a heavier amount of mass. All right, and this was also alluded to with page 80, the numbers 5 and 6, I believe, were asking about like objects that would be affected by air resistance versus those that would not be. And a lot of you put the fact that a human being would not be so much affected by that. Kind of concerns me because you're imagining dropping someone in free fall. I don't know, but anyway, I guess that was my attempt at humor. So what we got here for number 48. These three equations here are three equations that we've dealt with throughout the chapter. This is final velocity with average acceleration. This is position with average acceleration. These two formulas were also focused on when we talked about free fall, where the acceleration was just 9.8. And then this equation here is constant velocity, or final velocity with constant acceleration. Now, that being said, you really had to stop and think about which formula am I going to use to solve this problem about the sister dropping your house keys out to you. The height was 4.3 meters. That's the distance that the keys fell. Now, they only gave you one number in there, and that's the distance. All right, so this formula here, v sub f equals v sub I plus a times delta t, doesn't factor in distance at all, so this one's out of the equation. This one's really not going to work either because, yeah, you know the initial speed, but you don't know the time. And some of you put, a couple of people put, oh, well, I don't know the time, I can't solve this. I said, well, yes, you can. And so this formula here, you know the distance, you're accounting for the acceleration due to gravity, and you're trying to figure out how fast the keys were traveling just before they landed in your hand. So, setting up the problem here, the keys were initially held in your sister's hand, so that the initial velocity is 0. You have 2, the constant of 2, times acceleration due to gravity, it's always 9.8, times the distance. Then, this is just 0 squared, so that you can just get rid of that. So you have v sub f squared equals the product of 2 times 9.8 times 4.3. That gives you 84.28. Now, some of you stopped when you said 84.28 meters per second, or 84.28 meters per second. The problem is that's v sub f squared. I wouldn't want to try to catch something that's coming and landing in my hand while it's traveling 84 meters per second. Your hand's going to hurt pretty bad if you would let that happen. So this is v sub f squared. What you have to remember to do, and please remember to do this like when you're taking the chapter test, which is on Edulastic, you have to remember to take the square root of both sides. V sub f squared is 84.28. V sub f is 9.18 meters per second. And that's your final answer. If you have the urge to put a direction in there, you can put downward. All right? It's implied, but if you want to write that, that's fine. I saw 1 or 2 people wrote south, which I see why you did that, but those ordinal directions really weren't specified. So 9.18 or so, or 9.2 meters per second. So that's number 48. Now, number 49. You're talking about a free fall ride in an amusement park. You had 2 questions to answer there. The first question was, what's the velocity of the ride after 2.3 seconds? The ride was starting from rest. All right, it says starts from rest. All right, and you're being dropped. Think of the demon drop, I think it's called, at Cedar Point. Don't know if it's still there, but anyway. You have 9.8 times 2.3. Acceleration due to gravity times the time. This multiplies 2 numbers together. You're not factoring in air resistance, so yeah, your answer is going to be 22.54 meters per second. All right, you just multiply the numbers and you're good. Now, that answers the first question. The second question, how far do people on the ride fall during the 2.3 second time period? All right, so you're solving for a distance. A lot of you came up with 28.22, I believe it was, and I know why you did that. You have to remember to follow the order of operations. You do all multiplication first, you know, the whole PEMDAS thing. Do all multiplication first, so you have 1/2 times 9.8 times 2.3 squared, right, based on the formula here. That gives you 25.292 meters. Now, over here, you have 0 times 2.3. All right, 0 times 2.3 is 0. So this is all just 0. So really, you're focusing on everything to the right of the plus sign. 1/2 times 9.8 times 2.3 squared. When you multiply those three numbers together, you square the 2.3, you get 25.92 meters. Some of you might have rounded up to 26, and that's fine. All right, so that's number 49. Number 50. We're talking about the acceleration due to gravity on Mars versus Earth. In the information I provided you, I said that Mars, the acceleration due to gravity on Mars is about 1/3 of what it is on Earth. Okay, so it's less than half of the value. If you think about 9.8, some of you did this. Some of you said, okay, I know that the acceleration due to gravity on Earth is 9.8, so I can in essence divide that by 3 and get 3.3 something or 3.29, whatever it is. So the first question, how would the ball's maximum height compare to that on Mars? Be specific. All right. Most of you, in fact, all of you, I believe, said it goes higher. You're right. How much higher? You have to quantify things. In physics, we have to quantify everything, which means we put numbers and units with it. So it's not just the fact that the ball went higher, it's the fact that it went about 3 times as higher. Because again, the gravity is 1/3 about what it is on Earth, right, relative to Mars. Okay? Now, so the ball went 3 times higher, all right, and then it was asking about the flight time. Well, it's about 3 times longer. All right, it's just the inverse of 1/3, which of course is 3. So that's how you handle that one. So if you lost a point there, it's just because you really weren't quite specific enough. You had to, again, include that quantitative measurement there, 3 times higher. And number 51. Suppose you throw a ball straight up into the air, describe the changes in the velocity of the ball, describe the changes in the acceleration of the ball. And again, in both cases, be specific. I kind of abbreviated this here, but some of you, in fact, a lot of you probably saw what I actually wrote because I took what I had on my key and copied and pasted it onto your paper for you, so that way you have the correct information. So again, the velocity of the ball is going to increase with altitude. Actually, it's going to decrease. That's my mistake. At a constant rate. At a highest point, velocity is going to be 0, and that's instantaneous. All right, it's literally a split second. And then it's going to increase until the height of the release at that point. Or at that point, the ball has the same velocity as it did upon its release. Remember, throughout this process, when you're throwing a ball up in the air and it's coming back down, the acceleration stays constant. All right, the acceleration due to gravity, because we're talking about planet Earth, it's still 9.8 meters per second squared, regardless of anything else. All right, so the acceleration is constant. I hope this video was useful to you, helpful to you. As always, if you have questions, feel free to email me, or if you want me to come, we can meet in a small group or whatever you need. Whatever you want, that's fine. Anyways, I hope this was helpful for you, and that chapter test again is on Edulastic, so make sure you take care of that by this coming Tuesday, the 17th of November at 11:59 p.m.